Tom, we have yet another leftover question from the last Fireside Chat. This comes from Tim C. The system's awareness of your experiments. These experiments you devised are intended to help the inevitable shift from physicalism to a new paradigm. Do you think the system is perhaps aware of what you're doing and putting roadblocks in your way that have kept these from being released sooner? I wonder about this sometimes if the system knows that you are trying to reveal the magician's tricks and show us how reality is an illusion. I ask this out of humor because I assume the system would support a person trying to teach us that reality is virtual. You said once that there is a pervasive ignorance of the nature of reality in all reality frames. I think about this idea a lot. This means even beings in the non physical are just as ignorant as us. You don't become smart by dying. Love you, love your work. I've been a student since 2010.
Yes, uh, I'd be glad to answer that question. No, I don't think the system is putting any blocks in my way. I think that the experiments are just a lot harder to do than I thought they were. They're so simple from the theoretical point. I can draw my little diagrams and point the little arrows and make the slits and explain them very, very simply. Conceptually, they're so simple that it seems like, well, surely they can just do this, make a contraption that does this. But as it turns out, that's a pretty hard thing to do. It's a very difficult thing to do. Looking at trying to measure photons as they fly around at the speed of light, it's a hard thing to do. And even if you shift it up to electrons or other particles, they're really hard to manage, hard to do, hard to measure, hard to affect, hard to measure like the which way data without affecting the trajectory of the electron. So in any case, these experiments are just not easy. So what I'm doing when I first put them out there, I said, "Oh, right, gee, in a couple of months, just do these experiments." Well, that turned out not to be true at all. I was a theorist, and the theory is simple enough, but the actual hardware to make it work is not so simple. So I I think that they will dramatically provide evidence for my viewpoint that this is a virtual reality. They will do that, and even for the fact that the consciousness is the computer. I think it'll shed some light on that as well. But they're going to be hard to do. Now, my solution to that is if I can get enough donors, if I can get enough wealthy people, well, money helps make things happen. It just is like that. If you have money, then you have interest. People are interested in your experiment. They think about it. They'd like to do it because they'd like to get paid to do it, or they'd like to win a prize to do it. Whatever. It helps. Boy, looks like I got a terrible suntan here, doesn't it? That's because the light is dimming. We're going into the later afternoon and the light's dimming outside. I'm sorry to be turning into a fire engine right in front of you. Let me open this a little bit here and see if I can't regain some of my humanity. There we go. That's better. Okay. Just opened the blind a little bit to get some more natural light, but even that's going to fade in the next 15 minutes or so. So anyway, they are hard experiments to do. And I was wrong in that these wouldn't be so hard and we could do these. I thought that experimental science was a lot further along than it is. The first really good double slit experiment wasn't actually performed until about the 1970s. And the first one that showed that or that worked in such a way that the which way data didn't touch the particle that went to the screen. It was done with entangled particles. That wasn't published until the year 2000. So that is that's pretty current. So we're just in the baby stage now of being able to do these experiments with the technology that we have. I was first thinking that the double slit experiment was actually performed back in the 1920s when they talked about it. But what they could do at that time is just send particles one at a time through two slits and see that they got an interference pattern. That they were able to do. So they knew the effect, but they weren't able to collect which way data. That's the hard part. So you see, they did know that something magical happened because particles supposed to travel in straight lines. They're not supposed to magically distribute themselves into interference patterns. And that was a really big deal. And from that, they determined that our reality was not physical because physical things don't act like that. Physical things travel in straight lines unless acted on by external forces, and they just pile up behind a slit. That's what they do. So obviously, these particles weren't physical because physical things don't work that way. So what were they? And their studies showed them that it was probability. They came to the conclusion that our reality was probability based. And that's what then led them to the idea that consciousness was involved, had something to do with consciousness. So it got there through that channel, not because they actually measured which way data and did that experiment. That didn't happen till much later.
So they knew the observer was the key.
They knew that the observer was the key. Now, here's how they knew the observer was the key. All right, you have the fundamental reality is in probability. But when you observe it, you don't get a probability, you get an answer. That means that the observer makes that probability collapse into a fact in this reality, you see. So that's where the observer effect came from. It takes a person to look, and then the fact comes out. But if nobody looks, it stays probability. So that was the observer effect. Life happened because people made measurements. When you make the measurement, you get a result, a physical result. But until you make the measurement, there is no physical result. There's only probability. And that's true whether a human makes the measurement or I guess whether a dog makes a measurement. You know, when anybody does something to get a physical result, then the system will produce that physical result by taking a random draw from the probability distribution of the possibilities, right? That's what happens. So, right when some being, some conscious being says, all right, I'm making a measurement. What's under this rock? Well, they pick up a rock and they look under it. And right as they look under it, the system has to download to them the answer. What's under that rock? Dirt, another stone, pebbles, a coin. What's under the rock? Well, it looks at the probability. What's the highest probability? Probably dirt. That's all. Maybe a centipede, maybe a worm. So it goes into those probabilities, and that is what it produces, drawn out of probabilities. That's the nature of our reality. And you don't get that until a measurement's made. A measurement can only be made by consciousness. Rocks don't make measurements. People make measurements, you see. So if you have a conscious entity, they can make a measurement and get an answer. So that's what brought consciousness in. Reality was shown to be probability. It didn't exist in a physical state. It only existed in a probability state. But when a consciousness comes up and says, all right, what's going to happen here? How are these electrons going to hit this screen? I'm going to stick a screen up here, and these photons, I mean, they come through the slits. They're going to hit that screen one way or another. They're going to pile up in a pile. They're going to do something. All right. Every time one of those little photons gets ready to hit the screen, a random draw from the probability distribution of the possibility is taken. It says, the probability says it's there. Probability says it's there. The probability says it's there. And after 1,000 of those come through with all those dots, you get an interference pattern. Why? Because not to get an interference pattern would have caused a direct, what should we call it, conflict with science that had been around for 100 years called optics. Because when you put waves through a double slit, you get an interference pattern. So light was a wave. Now we find out that light, from the photoelectric effect, Einstein, I think, a Nobel Prize for that. Found out that light really carried little chunks of momenta, which means it was a particle. All right, then they said, well, let's just put one particle at a time through and see what they do, because we know particles have to travel in straight lines. And what they found out is if that was the case, there would have been a conflict, because you see, if you send one at a time through or hundreds at a time through, makes no difference. You have to get the same thing. Those photons do not interact with each other. So even if there's a billion of them going through that slit at a time, they're totally non-interactive. It's not like they talk to each other, make friends, bump into each other, anything like that. They're all totally independent. Well, if they're all totally independent, then whether a million go through or one goes through, you're going to get the same result because they're all independent. It's just whether they go through now or later doesn't make any difference. That's what you're going to get. So the system didn't want to allow this conflict in science, that you had optics said one thing, and then when you let these go one at a time, which should have given you the exact same answer, and it doesn't. There was a conflict there. Oh, we found a hole in reality. There's a conflict. We got two things we've done that must have the same answer, but they don't. Well, rather than have that kind of a conflict in the reality, because the system likes this reality to stay nice and smooth and believable, so it said, well, okay, I will give it a probability pattern that looks just like the interference pattern. So then it goes up out of that interference pattern probability, takes a random draw, gets a dot, takes another random draw, gets a dot, and eventually that probability pattern is what you see on the screen. And that probability pattern is exactly the same as for optics with waves. Now there's no conflict. There's no logical discontinuity in the reality. So that's why the system made that choice. See, the system, I've said it this way before, it's like you put the larger conscious system between a rock and a hard place. You made it have to come up with something. Either it was going to give you a logical inconsistency in the reality, or it was going to have to come up with a new trick. Well, it came up with a new trick, and that was these particles were located by that random draw from the probability distribution of the possibilities. That was made to be exactly the same as the result that you get with waves in optics. That way, no logical conflict in science. And the reason is a logical conflict, I said, is because all the particles are independent. So whether they're one at a time or a million at a time, they should do exactly the same thing. They're all independent. There's no interactions. So you see, that was the problem. So the scientists looked at that and they said, okay, the only way this can happen is that reality is probable. And when you look, when you make a measurement, now making the measurement was putting a screen up, and the particles had to hit the screen. Well, when they hit the screen, they left a dot. In the old days, that was film. Light hits a film, leaves a dot. You see, so it's a piece of film. So when light hit it, it made a made a little dot, and so on. And you added all the dots up, and you ended up with an interference pattern, just like the pattern you got when they thought they were waves. No logical inconsistency. Okay, you put the larger conscious system between a rock and a hard place, and what it chose was no logical inconsistency in the virtual reality, but now there's a mystery that wasn't there before. So no logical inconsistency, but a mystery is, why did those photons, for no particular reason, without any exterior forces, just arrange themselves in an interference pattern? big mystery. You see, so that's kind of the mystery of quantum mechanics. That makes it weird physics, right? Weird science. So that's where all that comes from. So the observer effect was the fact that until it's observed, there is no reality. It's not in our reality until it's observed. And when we make the observation or the measurement, putting up a screen for the photon to make a dot on, that's a measurement. You see? So we force it to a physical answer. And when we force it to a physical answer, then we get this random draw from the probability distribution of the possibilities, because reality is basically a virtual reality. It's probability based. So that was their thoughts. And because then reality was basically created by taking measurements, by observing. Every time we look with our eyes, we're taking measurements. Every time we hear something, that's a measurement. Feel something, taste something, smell something, that's a measurement. All of our sense data is constantly taking measurements. And as we take measurements, we cause things to happen. Reality is a certain way. And how is it? It's according to the rule set. This is a virtual reality. So you'll get a result. And in that particular result, with the double slit, where we put the system between a rock and a hard place, was it had two conflicting sets of data there. And it wasn't clear how that would work out, but the system made a choice. It could have made the choice, okay, I'll just leave a logical inconsistency in the reality. It could have done that. Or it chose rather to let those particles arrange themselves in a pattern that was outside of the ability of material particles to do. Big hint to us, right? That this wasn't a material reality. This is not physicalism here. This is something else. This is probability. You see? So the system gave us a really big hint there that this is not a physical reality.
A
It's a
logical inconsistency is not something it wanted to do.
no, the system doesn't want its virtual reality to have logical inconsistencies in it. That's a no-no. It's not a good thing for virtual realities to have logical inconsistencies in them. It makes it a poor virtual reality. And it made a big pointer to the fact that this reality is probability based. How do you get a probability based reality? How's that possible? Well, there's only one way to get an information based, right? Probability based means information based. Probability is information. What the probability is a piece of information. So the only way to get an information-based reality is if it's a virtual reality, a reality created from information. You see, it's just obvious. You know, if you think about it, it's just obvious, but the people back in the 1920s couldn't come up with that because the idea of a virtual reality, a computed reality, just wasn't there. You know, they barely had anything called computers at that time. They probably didn't have anything called computers at that time. It was before just the concept of being able to compute a reality was just ridiculous, you know, idea. So now it isn't. We have virtual realities that are very, very real. And if you've ever put on the goggles and gotten into them, you realize that you react. Your heart rate, your everything else reacts to that virtual reality just like it was a real reality. You know, it doesn't have a whole lot of difference other than it only does sight and sound, and the real reality also does smell, taste, and touch. That's the biggest difference. Now, when they get a suit that gives you smell, taste, and touch, you won't know the difference. You absolutely won't know any difference, you see. So that's kind of the origin of where all this comes from. And I was thinking that early on, they must have looked at the which way data and realized that when you measure the which way data, then you are looking. To measure the which way data is a measurement. So that's the looking. If you measure the which way data, you get a particle. If you get a particle, it goes in a straight line and it lands right behind a slit. They just surmised that. They didn't actually do it. in an experiment. It just was logically obvious. If you could look at what slit it goes through, if I can look at it going through the slit, that's a measurement. Turns it into a particle. Turn it into a particle, it's got to act like a particle. No interference pattern. You don't measure which way data. Now it stays probability all the way up to when it hits the screen. Now when it hits the screen, you get an interference pattern. See, so they just logically knew that that's the way it would happen. It would have to happen that way. They didn't actually do the experiment because it was too hard. They didn't actually collect which way data because that was too hard. They did do the experiment of sending one at a time through the double slits. That they did. That was seminal. But they didn't do the experiment of collecting which way data because that's a very difficult thing to do. It wasn't until 1960s going to 70s that the first attempts to do that were made, and it wasn't really to 1999, published in 2000, that a really fine, masterful job of it was done. So that's only 24 years ago that they were first able to really do a good job of that. And maybe, maybe 30 or 40 years ago that they actually did kind of a, they did a decent job of it maybe, but it wasn't as good as the one that was done and published in the year 2000. So that's kind of the way it goes. So I was thinking that, oh, surely they had done that experiment. They'd measured the which way data and they'd done all that. But no, they hadn't. They hadn't done that. They just logically surmised that because the measurement would cause the particle. The particle would go in a straight line. That gets you mass, whereas before it was just probability. So they had all that thought out, but not actually ever done it. So this experiment turned out to be a lot harder than I thought. And we've only been successful at it for a short time, and only because our technology has enabled us to do it. You see, now. So my experiments, oops, I need to open my blinds a little bit more. So I'm starting to turn red again. Well, that's about as far as they get. So we're going to have to wind this up or I'm going to turn into a sunburned fellow. My background's faded away, but my
Yeah.
face, my face is still visible. Okay. Ladies and gentlemen out there who are watching this, Donna doesn't cut this. That's because I'm facing a window and getting natural light, and it's getting late. And the
This
natural light,
happened.
you
Yeah,
know,
this happened.
the natural light is setting, shall we say. It's moving below the horizon, and it's just getting dark here.
Remember this happened to Ian McGilchrist. Anyway,
Oh yes.
do a little wrap-up sentence and we'll cut it.
Well, I think well, I don't think it's too bad to add this to the
Okay.
to the video. It's fine. It's life happens, and we're
Okay.
adjusting to it. It's fine. That's not a bad thing. So basically, the experiments are going to be hard to do,
Mm,
but they're never going to be done if you don't make them attractive to do.
yeah.
And the only way to make them attractive to do is publish them and hope people get interested. But you have to apply some money because equipment has to be bought. The ones that we are doing are costing around $100,000 a piece. That's what it costs to buy it, to have the paid salaries of the people doing it, and so on. So it costs about $100,000 to do it. So it's not cheap to hire people over, it takes time. They work on it now years. So it's not like it's something they whip up in the lab and do in a week. It's something that takes years to lay this stuff out. It's really difficult to do. So in any case, offering some money as an incentive and payment, because nobody's going to do it without money because it takes salary and it takes people and it takes time over years to do it, then we have to have some cash. So we're going to try very hard to get, to find some donors who can donate significant amounts of money,
If you
wealthy
could,
people who have more money than they need that are looking for good causes to donate to.
if you
We
could
we
explain to them, if you could ask, if you could condense what these experiments will mean, that would be the impetus for the people getting involved and those with the funds to donate would be interested. And how would you How would you condense the
Well,
importance of what these
I would
experiments are?
condense the importance of it to a video called Breakthrough. If you go watch the Breakthrough video, it will basically make that case exactly. I'll make it here in short, but it's much better made in Breakthrough. Basically, what that means is that if the experiments work out the way I think they will work out, then we will have some strong evidence that this is a virtual reality. Consciousness is the computer. Consciousness is fundamental. Okay, we will have not proof. We never get proof in science. We just get evidence. So we will have evidence pointing that direction. Now, what that'll do is take us back to the time in the 1920s when the founding fathers of quantum physics were all talking about consciousness being fundamental and so on, and that kind of got stamped out by the physicalists. Well, that will reemerge again because that's a logical argument, and that will mean that we will begin to see that this world is not a deterministic physicalist world. That changes everything. That changes everything. That idea, and a lot of people call physicalism materialism, but there is a little technical difference between the two, and this is really physicalism we're talking about. So if you're used to the word materialism, just imagine I'm saying materialism. It's the same thing. Just that concept comes with an attitude. It comes with an ethic. In a materialist world, in a physicalist world, the overriding ethic is control, power, force. You have beings in a physical world, and what they want to do is control what's outside of them, the environment and everything, to their liking. If it's too cold, they want warmth. If it's too warm, they want coolness. If it's too windy, they'd like shelter. They want to take the environment and mold their into something that's better for them. Well, their environment includes other people. You see, it's not just humans against the trees. It's me against everything else. That's my environment is all the trees and rocks and rivers, but also all the other people. So what we do is we try to manipulate everything else to be the way we want it. That's called self-centeredness. It's all about me. I want to be the master of the universe, but I'm not. But if I get enough money, I can pretend to be. So, in any case, we have this ethic of control, force, power. That's what a person wants. Well, we say, well, what does a person want here? They want money. Well, what's money? Money is control, power, force, because if you have money, then you have control. If you have money, you have power. If you have money, you can force things to be the way you want. Okay, so basically, that's the ethic that runs our world. Well, when you have an ethic of control, power, force, what do you get? You get a warlord mentality. You get fighting, you get grabbing, you get greed. You get people taking advantage of each other, people not being nice to each other. That's what you get. That's the world we've got. Okay. That has to do with the underlying belief we have that this is a materialist or physicalist world. It just goes with it. If you have a world where you realize that consciousness is fundamental, consciousness is non-physical, something in the non-physical is fundamental, you see, it starts to open up other ideas. Okay, and it's very easy to logically from that place to go to the larger conscious system. Love is the answer. Consciousness is an information system. All that just falls out as natural, logical. That's the only conclusions you can come to. So those aren't really opinions. That's logic
This
comes to those
reality,
conclusions.
this reality is about others. This
Yeah, so
reality is not about controlling
exactly,
others.
you see
This
that.
reality is about all of us are important, and it's about the caring about others.
Yes,
Mm.
that ethic, the ethic of the fact that this is consciousness is fundamental instead of material being fundamental. The ethic of consciousness is fundamental, is an ethic of love, peace, caring, helping, consideration, cooperation. That becomes the ethic because that becomes a low entropy way, and that's the way consciousness and information systems, that's how they evolve. So it just naturally turns out that that's your ethic. So when we move from a worldview of materialism, physicalism, that says the ethic here that we work by is control, power, force, well, we're going to have a nasty world where everybody's trying to rip off everybody else. Or we get this idea, oh, it's not like that. Consciousness is fundamental, just like all those physicists said, right, in the beginning. Consciousness is fundamental, and the ethic is caring. The ethic is cooperation, compassion. That's the ethic. Now, what kind of a reality would you get? Totally different, just the opposite. You would get an ethic that would be just part of your culture, that it's not ripping people off. It's not control, power, force is not a good thing. That's not a good thing at all. Being helpful, being useful. How can I help? What can I do? Not what can I get? And why should I help you? What's in it for me? You see? So one's self-centered and the other's other-centered. One's fear-centered and the other's love-centered. So, okay, what's the difference going to be? Well, if you live in an ethic that's love-centered, what you end up with is people being nice to each other. You end up in a loving, wonderful environment where people work together. If you live in a place that is materialist, determinist, physicalist, you're going to end up in a place where control, power, force is the coin of the realm. That's how you get things in a material world, is with control, power, and force. And if you don't have control and you don't have power and you don't have force, well, you're on the bottom of the barrel and everybody will abuse you. You see?
Well,
So
Tom, if
that's the
this
difference. So what difference does it make? I mean,
everything.
yeah, you ask this question. Well, if we do these experiments and it helps change our understanding of the nature of reality, it makes all the difference in the world. It makes a tremendous difference. Just that change in understanding the nature of reality would, not instantly, but over 4 or 5 decades, maybe a century, would create a totally different attitude, because you'd understand why you're here, what you're doing, what your purpose is. All of that would become clear. And no, it's not a religion. It's not like you could say, well, religions have always said that. Yeah, they have, but they've always been opinions. Philosophies have always said, be nice, but that's just opinion. It doesn't hold any water in a materialist. It's not a fact. But when it becomes a fact, because this is a love-based reality, not a material-based reality, not a control, power, force-based reality, then those things are facts. It's just the way it is. They're not opinions anymore. That's the nature of reality. Consciousness is fundamental, and the logical consequences of that is that caring, compassion, cooperation become the ethic of that reality. And it's no religion. No, you don't have to put money in a collection plate. No, there's nothing to believe. It's just a better physics that explains the world better. And from the physics viewpoint, all of the things that are unknown, all of the paradoxes.
Yeah.
Why are things like that? Like the double slit experiment, it's a paradox. All the paradoxes fall out as easily understood. You can explain them all precisely. The anthropic principle, why did all these constants, why are they all tuned to 8 decimal places? Why is that? See, there's no explanation of that. Why does the speed of light change a little bit in the 8th decimal place? Why is it a constant? Mostly a constant, except for a little change every once in a while. But why is it like that? Nobody knows. Why does quantum physics do the things it does? Nobody knows. Well, all those things become logically derived once you change this attitude. So what is it going to change? What would the difference be if you gave money? If you were wealthy and had extra money and you gave it and it actually helped and it worked, it would change everything. It would change the whole world.
It would
It
change the
would,
future.
it
It
would,
would
it,
be a kinder, gentler place. If
yeah,
this doesn't inspire you, I don't know what
yeah.
will.
It would instigate a paradigm shift that's been bigger than all the paradigm shifts we had before. Now, we've had paradigm shifts. The first big paradigm shift was when we shift from hunter-gatherers, nomads wandering around on the planet to farmers, right? We found that we didn't have to wander around and stay one place until we killed all the game and used up all the richness in the soil and moved on to despoil some other place. We could actually farm and take care of the land and take care of the animals, and we could get by that way much better. Give us a lot extra time. We don't have to work so hard all the time. And the next big paradigm shift was probably the Iron Age. You know, each one of these big paradigm shifts give us a whole new age. It was the Iron Age. And then after the Iron Age, we had a whole bunch of other metals that were kind of subsets to the Iron Age, which was what the Bronze Age, and then I think it was the well, first, what had first came? I guess lead was first. You know, they found lead, and they used lead because it was a soft metal that they could work. And then they found tin and iron and
Mhm.
steel, and it goes on up. But those are all kind of subsets to the finding the metals. Changed everything. Everything, you know, you had a sword that would keep a sharp edge for a long time, changed everything. If you had those and your enemy didn't, well, you'd win. So it was a big deal. And then we had the Industrial Revolution, the Industrial Age. Changed everything. And now what do we have? The information age. Guess what? Consciousness is an information system. Here we are in the information age. And this is where we finally understand the nature of our reality.
And when you say consciousness is the computer, that's an analogy. That is something that can be
It's a
um,
metaphor.
a metaphor.
Yeah.
It is a
It's a good
metaphor.
metaphor. It works very well.
Yeah,
It's a pretty accurate metaphor, but
yeah.
it's a metaphor. Yeah.
Well, thank you so
Anyway,
much
so
for
that
this.
kind of tells us. I see my bookshelves in the back are almost
Yeah,
totally blacked out
we're
now as the light
we're fading. We're losing daylight.
yeah, as the daylight disappears,
It's all
they
right.
just
This was really, really interesting. Thank you so much for this, and thanks for the question that inspired this. Thanks,
okay,
Tom.
well, good. This will maybe help some people see a bigger picture.
Yeah, I liked this as much as I liked Breakthrough. That was
Yeah,
really fascinating. Thank
yeah,
you.
yeah. Well, what difference does it make? Okay.
Oh,
If I give you this money and this helps, what difference would it make? A bigger impact than anything that's ever happened in the world before. That's
the
all.
mic drop.
Yeah, that's
And
all. Nothing special, just
no,
bigger than anything that's ever happened in the
just
entire
a
history of
little.
humanity.
Yeah,
Yes, we would go from a control power force to a caring, compassionate people.
I think the time is right. We need this now.
Yeah,
Thank you so much.
you're welcome.